Okay, so now it's time to run our gradient descent. I'm going to scroll down a little bit, hit the plus sign, add a few cells, and this cell I'm going to convert to markdown, and I'm going to call this cell the subheading batch gradient descent with SymPy. Hit Shift Enter. Now with gradient descent, the first thing is we're going to do a bit of setup. We're going to provide the initial values or the parameters, and we're going to specify these up top. And these were things like the multiplier and the maximum number of iterations. So I'm going to say multiplier is equal to 0.1. I'm going to say the max underscore iter is equal to 200. And now I'm going to supply my initial values. So previously we've, had a single variable, and we've just said, new x is equal to, and then there was our guess, like 1.8 or something. But this time we have two values. So how are we going to do this time? Well, if you have two or more values, the best data structure to work with is a NumPy array. So I'm going to say params is equal to np array, open parentheses, square brackets, and then I'm going to supply two values. Our initial guess for x, which is going to be 1.8, and a comma, and then our initial guess for our y, which is going to be 1.0. And this is our initial guess. So I'll put that in a comment in the same line after the Python code. Now, one thing that you'll see when we write our loop is just how convenient this is, because the params is going to hold the values that we actually care about optimizing. It has our x and our y values, and these need to be changed to get to the lowest cost. Previously, we only had to worry about one variable, and we were using previous underscore x and new underscore x inside our loop. But this time we're going to switch it up and write it a little differently, because we're working with a collection instead. Our loop is going to have a very, very similar syntax as before. We're going to say for n in range, and then provide the maximum number of iterations, colon, do something. Step one is going to be working out the slope. Now, if you remember, the slope that we had up here was diff f of a and b with respect to a dot eval f, and then substituting a particular value. So this is actually the format we're going to be using. So what's our gradient going to be in the x direction? I'm going to create a variable called gradient underscore x and set it equal to, you guessed it, it's diff f of a and b, comma a. This is going to be our cost function differentiated with respect to x, dot eval f, open parentheses, and then we're going to substitute some values. We're going to say subs is equal to, and then we're going to provide that dictionary. So curly braces, and we're going to say a is going to be equal to what? It's going to be equal to the first element in our parameter array. It's going to be params, square brackets, first element is at 0. And then for our b, we're going to say b semicolon params square brackets and then 1. So there's a lot going on in this line here. And this is why we've practiced in the cell above a little bit to make sure we can get our head around all of this nesting of the code. But we're differentiating our cost function with respect to one of the parameters, with respect to a, and then we're evaluating the slope. We're asking Python to figure out what the value is of the slope at a particular point. Which point is that? It's going to be the values in our parameter array. So param0 and params1. The very, very first time this loop runs, those are going to be equal to our initial guess. So as a challenge, can you create a variable called gradient underscore y, and then complete the rest of the code, can you write the Python code that calculates the value of our slope in the y direction? I'll give you a few seconds to pause the video and have a go at this. And here's the solution. Again, we're using diff parentheses f of a and b, and this time we're not going to be differentiating our cost function with respect to a, we're going to be differentiating it with respect to b, because b is our second parameter. And I'm going to put a dot after it. I'm going to say eval f, and I'm going to substitute the same dictionary. I'm going to say a colon params square brackets 0, comma, b colon params square brackets 1. I made a typo in params, so I'm going to fix that. And this is my finished Python code for our gradients. Now I've split this up a little bit to make it a bit easier to read. But I said earlier, what we actually want to do is we want to work with arrays primarily, because if you're working with more than one value, it's handy to work with NumPy arrays. So let's combine these two values into a single NumPy array. So I'm going to say gradients is equal to np array parentheses and then square brackets gradient underscore x comma gradient underscore y, closing square brackets, closing parentheses. So in these 3 lines of code, we have calculated our cost. We have calculated how far away we are from the minimum based on the steepness of the slope. So the next step is updating our parameters. This is the learning step. The most important part of our loop, right? And because we've written our Python code and used NumPy arrays, we can actually work with this in a very, very nice and easy to read manner. We can say our new value of our parameter array, so params is equal to, it should be equal to our old values, so params minus the multiplier times our gradients array. So we're multiplying our gradients array with the learning rate. So the learning rate times all the slopes is going to be subtracted from the current values of our parameters. So this is updating them. And then we're storing those values inside the parameter array. So we're replacing the values inside the parameters, the old ones, with the new ones. So these are the old ones on the right-hand side of the equation. We're doing some calculation with them, and then we're overriding those values in our parameter array by updating them. This is what this line of code does. And that's our for loop done. It's just 4 lines of code. Now it's time to maybe print out the results. So I'm going to say $, results, and then we're going to print out maybe the values in our gradient array, so we can see the values of our slopes. So I'm going to say values in gradient array, comma, gradients. I'm going to print out the final value of our x, so after the optimization has run. So I'm going to say minimum occurs at x value of, and then where's the final optimized value going to be stored? Well, it's going to be stored in our parameter array at value 0, first value in our parameter array. And I'm also going to print out the minimum occurs at y value of, and this is going to be the second value in our parameter array. It's going to be at index 1. And finally, I'm going to print out what the cost is at these x and y values. So I'm going to say the cost is as a string, then a comma, and then how do I calculate the cost at the final values of our x and y, the optimized values. I'm going to have to substitute them into our cost function, which is f, and then the first parameter is going to be params, square brackets 0, and then a comma, and then params, square bracket 1. And that's it. Now that's all I have to do is check if I've made any typos, and then run this cell. See what we get. Here we go. So we can see here that the minimum cost is around 0.5, and that our x and y values are actually very, very small. If we look at our chart up here, then we can see that this minimum is probably going to occur where x and y are equal to 0. And on the z-axis, we know that this is probably going to be around 1/2. Scrolling back down to our cell here, let's see if this is true. Let's see what happens if I run this cell instead of 200 times, maybe 500 times, and hit Shift-Enter. Got to wait a little longer. This code takes some time to execute. And I can see here, indeed, our minimum cost is definitely 0.5, and our x and y values have gotten very, very, very small. So that's really, really cool, right? We've been able to keep our mathematics that we had to do by hand to a minimum. Having a conceptual understanding of what's going on got us very, very far. And we also saw the power of working with arrays and being able to update a whole bunch of values at once. And in addition, we learned a little bit about a new data structure, namely dictionaries, which associate values with a key. So you have a key value pair. And on that note, I think I'm going to get some more coffee or something. I'll see you in the next lesson. Take care.